Hello everyone, we would like to introduce a demonstration about the paper prediction of game churn through reinforcement learning based player simulation. The proposed system can be illustrated by this graph, which consists of three parts: reinforcement learning based player simulation, game churn prediction, and human-AI interaction. As we can see, the workflow of our system can be explained as a closed-loop control system. At first, the game designer selects a set of parameter values of the gameplay and starts the player simulation process through training agents by reinforcement learning. After convergence, the learned policy is applied to generate agents matrix data. After that, the matrix data are fed into the churn rule generated by the game churn prediction part. The game designer receives the predicted churn ratio of each group and fine-tunes parameter values of gameplay to obtain a more appropriate gameplay. To better understand this, we build a website from the perspective of the user of our system, which is the game designer, and also a Unity-based video game is provided. At the top of the website, it's the description. We can skip this part. The yellow block is where the game designer selects the set of parameter values in the gameplay. Here we get 7 choices. We can have much more actually, but it requires training which might take a few days. So we list 7 choices only with pre-trained results. Once the game designer decides and clicks submit button, there should have been a training process enabled to train agents in the video games with selected parameter values, which might take about 3 days. To avoid the long training process, we provide the results directly, as we can see here and here. The game retention ratio of different groups is highlighted in the blue block by the color yellow. A video about agents' behavior is also provided. Here we would like to dive into the video and analyze agents' behavior based on the usage of the attack to explain the results. In the video game, there are 100 agents and they are divided into 6 different groups. Different groups have different power levels. Each agent has to fight against or cooperate with others to obtain a key at first 2 stages to enter the next stage, where lots of rewards are put. The blue agent is normal and will become green when it dies. The health point will decrease when hit by purple light shot by other agents. The agent who has a key is purple and will drop its key when it gets killed. The agent who has a key at the last minute of the first 2 stages can enter the final stage. Here we can see through this video, agents rarely use attack, which is purple light. Now we take 2 different sets of parameter values as example, which are 200, 100, and 10.5. The former one represents more resources. Thus, agents tend to cooperate and not attack others, as we can see from the video. And let's go through the 10.5 first. As we can see through the video, agents try to attack others more frequently than in 200, 100. Which means in 10.5 the less resources are provided, and agents tend to kill others to obtain a key and win. Thus, in the 10.5, the more powerful players are, the better game experience they can get, which explains the reason why the most powerful group 6 obtain highest game retention ratio here, which is nearly 0.5. Nearly half agents love this game. However, in 200 and 100, the group 6 does not like to play this game anymore. Thanks for your watching. That's all.